Hello everyone, in this video I will be demonstrating my assignment on secure file transfer using symmetric key encryption. The objective of this project is to securely transfer a file over an untrusted network using AES 256 encryption, RSA 2048 key exchange and HMAC SHA 256 to ensure data confidentiality, integrity and authentication. The problem statement requires us to encrypt files using AES 256 in CBC mode, to securely exchange the AES key using RSA 2048, to verify file integrity using HMAC SHA 256, and to prevent unauthorized access and tampering. This design follows a hybrid encryption model similar to real world systems like HTTPS. So let me first show the project structure. We have kaizen.py for RSA key generation, sender.py for encrypting and sending the file, receiver.py for decrypting and verifying this file, cryptoutils.py which handles encryption, decryption and HMACs, a key folder to store RSA keys, and a files folder for input files, and an output folder for encrypted and decrypted files. Uh, Now firstly I generate the RSA 2048 key pair for the receiver. Uh, so we see that the RSA key pair has been generated. The receiver generates a public key and a private key which will be shared with the sender, and the public key will be shared with the sender and the private key will remain secret. So this allows the senders to securely encrypt the AES keys. We can see that the keys are saved securely inside the keys directory. Now, next I run the sender application. Uh, the sender performs the following steps. Firstly, it generates a random AES-256 keys. It generates a random initialization vector or port. It encrypts the file using AES-256 CBCs. It computes an HMAC SHA-256 for integrity verification, and it encrypts the AES key using the receiver's RSA public key. Now running the sender.py file. The output shows that the generated 4, the compute HMACs, and the encrypted file, uh, the saved as the document.pdf.enc, the RSA encrypted AES keys. So this ensures the file is confidential and tamper proof. So now discussing why AES plus RSA together. It is so because AES is fast and suitable for encrypting large files. RSA is slow but excellent for securely exchanging keys. So combining both, we achieved efficient and secure file transfer. Now I run the receiver application. The receiver the receiver decrypts the AES keys using its RSA private keys. It verifies the HMAC to ensure file integrity. It decrypts the file using AES 256 and it restores the original file. Now running this file. The output confirms the HMAC verification process. It correct decryptions. It successfully restored the file. So finally, the system computes the SHA-256 hash of the original and decrypted files, and matching hashes confirms that the file was not altered and the transfer was successful. So this system ensures confidentiality using AES-256 keys, 256 encryptions, and integrity using HMAC's SHA-256, and authentication using RSA key exchange, and also secure key management using hybrid encryption. So to conclude this project, it demonstrates a secure file transfer system using industry standard cryptographic techniques. It fulfills all the requirements of the assignments and reflect real-world secure communication practice. Thank you.